Good afternoon. Sorry, good evening, everybody. This is just like a recap video of the first part of the class because the one we recorded it didn't play, so I have to do it again. So yeah, basically we treated cardiac axis in class today, and the definition of cardiac axis is just basically the direction of the overall electrical activity of the heart, and then it is measured in degrees. Okay, think of it like a compass and like a direction that electricity flow in the ventricles, right? So yeah, this is the chart showing everything we are going to be doing about this cardiac axis. So this chart we are going to be working with most of the time. Okay, and another thing to know, there are different type of axis. There's right axis deviation, there's left axis deviation. For this far it is extreme axis deviation. I want you to, because there are different names for it, and I want you to take it as extreme axis deviation. Okay, and then there's normal axis. Don't make the mistake of calling this normal axis deviation, because if it's normal there's no deviation at all. It is left axis deviation, right axis deviation, extreme axis deviation, and then normal axis. And another thing you need to notice is the values. Okay, you have to really know the values of this thing. So after you divide the circle into four parts like the normal way, and then you have to slash it and slash it again. Okay, so now we have AVL, AVR, AVF 1, 2, 3 on the should I say compass or on the circle sha, because there's no electrode, there are no chest electrodes in this place. Okay, sorry, I'm really tired. I just have to do this thing again. So yeah, AVL is minus 30 degrees, as you can see here. And another thing that you should take notice is that, because in your exam you're going to be drawing this circle for me, you should not go and put 30 degrees where 60 degrees supposed to be. 60 is more than 30 and it is a right angle triangle. Okay, see where they put their 30, see that it's the small part and this green part is the what, is the bigger part, showing us 60 degrees. Another thing you also need to note is that the down part is the positive side, the upper part is the negative side. Also, another thing you still need to note is that what, when it is positive, it means it is moving towards the lead, and when the lead is negative, it means it is what, moving away from the lead. That is another point. So now, like I said, this AVL is minus 30, one is 0 degree. You have to really cram all these degrees. Lead 2 is plus 60, AVF is plus 90, lead 3 is plus 120, there's plus or minus 180, then AVR is minus 150, and then minus 90 degrees. So that is just basically the lead. Another thing you also need to notice is the, should I say, the space of the each axis. Okay, so for normal axis is in this note here. Let me check. Now for normal axis is from what, minus 30 degrees to plus 90 degrees, and here is it on the graph, minus 30 to plus 90. You also have to cram this one too. Okay, left axis deviation is from minus 30 to minus 90. Right axis deviation is what, plus 90 to plus or minus 1. You see that it is different. Okay, see where right axis deviation is. So the position of the distance doesn't matter. Okay, that's why you need to learn the degrees. And extreme axis is from minus 90 to minus 150 degrees. So yeah, let's just go into checking for axis basically. Now axis is actually, no, we need to now check an ECG strip as, okay, this is the axis now. Let's go into that. Now, this is just the simple, easy method, like the first method though. The second video, the second method is there. So, okay, let me use this video. I think you guys have this one now. So, for lead one, sorry, for normal axis, lead one and lead two will be positive, positive, positive. So now why am I using lead one and lead two? Because if we're using, because we can also use lead three and AVF too. But then Why I'm not considering is because they are still going to be the same values with lead 3, sorry, with lead 2. See now, for that right axis is positive positive, lead 2 and lead 3 is positive positive, left axis negative negative. Even in AVF too, they have the same value with lead 2. Okay, it's just that sometimes lead 2 can be confusing, or it can be biphasic, so you check the lead 3 or the AVF. And biphasic means what? That a lead has equal opposite or negative. That is what a biphasic lead have. I explained that to you. So now for normal axis, positive positive. For right axis it is negative positive, and then for left axis it is positive negative. Now another important thing you also need to note is that this thing, it is always the R wave that you are looking at, the QRS complex, the R wave in the QRS complex, nothing concerned with any other one. Okay, now let's look at this place. Now you see lead 1, lead 2, lead 3, and I said we're going to be considering what? Lead 1. Lead 1 is positive, lead 2 is positive. That is normal axis division. Positive just basically means it's facing up, negative means it is facing down. And I told you that if it is positive, it's moving towards that lead, and if it is negative, it's moving away from the lead. Now check the second one now. Lead 1 is positive, lead 2 is negative. It is what? Left axis division, as I told you in the distance. So you just have to look for a way to just memorize the parameters. And when you memorize parameters, it's going to be very, very easy. So look at one now. Lead 1 is negative, lead 2 is positive, it is right axis deviation. So let's just take a short quiz. I think I sent it to you guys. Let's just take a short quiz on this. I'm coming, because in the other distance we did an so we did a quiz for those that did not join the class. Is it even this one? No, it's not this one. And then we share the link. I actually thought that I shared it. Let me send it to the group now. God, I'm so tired. I've not eaten anything this night. These people are reading, sha, and you're not wasting my efforts. So let's go to the quiz. I've sent the link to you, so you should practice it well. So you see that now lead 1 is negative, lead 2 is positive. According to the parameter, this is a right axis division. This one is positive positive, normal axis division. You can see the correct this thing. So this is negative positive, it is negative positive, which is right axis division. Positive negative is left axis division. Positive positive is normal axis division. Negative positive is right axis division. Negative negative is now you can see negative negative, and there's no extreme axis deviation here. So let's consider lead 3. Negative positive, that is right axis division. See that it was what? It was correct. So we have another negative positive, also right axis. Negative negative is not there. Negative positive, yeah. Positive negative is left axis division. Negative negative, extreme axis is not here. Let's use the 3. Negative positive is what? Right axis. Negative positive, why are we just having negative positive like this? Another negative positive again. Even another one. Okay, positive positive, positive positive, positive positive, positive positive, positive negative, left, positive negative, left, negative positive, right. I hope you guys are understanding what I'm doing now. Can you see? We have been correct all through. So it's very, very easy. From the graph, you should be able to determine okay, this person has left axis normal, right axis deviation or extreme axis deviation. So let's just do it till we reach 30. This is negative positive, right axis deviation, positive positive, positive negative, left axis deviation, positive negative, left axis, positive positive. So that is just basically what this axis is saying. And I already explained the second part in the second video, I'm going to upload both of them. And then the courses of this ones, you just have to, learn it. It's not really this thing like that. So, but you need to learn because it's going to come out in test. So, yep, that's just all for this class. Thank you.